boa tarde. É prazer estar aqui com vocês hoje. But I'm going to switch to English immediately because you don't want to hear my 6-year-old Portuguese for the rest of this talk. So I'm here to show you a case study that I would describe as being extreme product design. So, and by that I mean really where technology begins to encroach on a new frontier of how people interact with it. I think it's a really useful case study for two reasons. One, it begins to give you a peek into the future of a future perhaps that none of us are really completely ready for. And two, it also shows that some of these best practices that you've been hearing about can really be applied to a lot of different types of technological solutions. So if you read any press and you see TV, you know that wearables are really a big deal these days. But you know, there's nothing new about wearables. Eyeglasses and watches have been around for hundreds of years. Not a big deal. We've added technology to them, and that makes them more capable. But they're limited by the fact that they're on the exterior of your body. What happens next is what's possible when the devices go inside your body. And it sounds like science fiction. But in fact, if you look around the web, you can find headlines like this, where there are predictions about the future of implants, and you can think of them in terms of cyborgs and androids, and we're used to talking about this in terms of science fiction. And sure enough, you know, here's a claim all the way from 2014 about the fact that people are going to get technology inside their bodies. And now let's fast forward to summer of 2017. And here's the reality. In the United States, a company offering to put devices inside their employees' bodies. And the promise is really interesting, right? Some of you probably have cars with fobs where you can step up to the door and it unlocks automatically. Imagine that being able to unlock your door, make payments, all kinds of things. There's a tremendous amount of promise there. We, as a company, as a consulting company, have worked on the problem of implants for over 7 years now, specifically for medical use. But it's really the beginning of a whole new generation of devices that go inside the body. To help you understand some of the work that we did, I'm going to give you a 1-minute primer into the technology that we used. So one of the solutions we worked on is called spinal cord stimulation. The idea is you take electrodes, you plant them along the body of the spine, you connect it to a computing device that's controlled by a remote control, by the way, that you hold. And when you're feeling pain through extremities and through nerve endings, you in essence can create white noise in the spinal column such that your brain can't interpret the pain signal anymore. And it feels more like buzzing. It's called paresthesia. Okay? So this is for people that have extreme pain in some parts of their body. The reality is when you put a device, I'm not going to show you too much gross stuff, by the way, so don't worry about it. The reality is that when you put a device inside your body, it comes with all the risks of surgery. So this is what surgery actually looks like for this type of implant. One for the computing device and one for the electrode placement that goes inside. Okay. Because these devices often require recharging, they often visibly protrude in the body as well. That's part of the reality of wearing this type of implant. That's a self-portrait, by the way, in case you were curious about it. So, you know, often these devices are recharged through inductance, and there's actually heat involved, et cetera. So that's one kind of technology we worked with. The other kind is called deep brain stimulation. In this kind of procedure, you actually drive electrodes into the human brain to stimulate a part of the brain that gives you some benefit. I mean, ultimately, we're an electrical system, and as part of that electrical system, by applying the right amount of voltage in the right place at the right time, you can have tremendously beneficial results. Just like the spine, it has computing devices that go on the body. The exception for this one is that the electrodes and the electricity are actually directly in the brain itself. To do this procedure, it's a little bit more complicated. What you see on the left is people's heads have to be fixated permanently, in essence, during the procedure to drive the electrodes. And what makes this procedure particularly unusual is the patient has to be awake throughout the whole process so that they can measure if their speech is being affected or whether their body is being affected. As part of the work that we did, I went into live surgery, and I had the experience of being on one side of the plastic draping, seeing a person's brain pulsating with their heartbeat, walking over to the other side of the draping, and seeing them on their iPhone telling their wife that everything was okay. And that was a really extraordinary experience to see that, as you might imagine. So that's deep brain stimulation. But, I could explain a lot more, but I think seeing is believing in terms of the benefit of this type of technology. So if you would play the video, please. So this is a patient who has Parkinson's type of symptoms. So can you play the video? Or this is the song and dance portion of the... Is the video going to come? It's going back there. Okay. So as you can see, this person has rigidity in their body. And if these diseases are not just something that afflicts the individual, it afflicts the family. It really has a profound impact on everything around them. And I actually cut the video here because it takes over a minute to make this turn. Now with this device turned on, same patient, same day. So as you can see, the potential for betterment of humanity is enormous for this type of technology. So how did we go about working on designing a product like this? Well, it began with doing a lot of research. We went into patients' homes to understand what their lives were like as pain patients or patients that had these types of symptoms. One of the interesting things that happened after the fact was that as researchers, we weren't really prepared for the emotional toll that dealing with these patients was really going to be involved. I'm not embarrassed to tell you that all of us who worked on this type of research at one point or another broke into tears in dealing with some of these situations. But it was something that, in terms of developing the empathy that was necessary to understand what these patients were going through and to do a really good design, it was something we had to commit to doing and that we did. One of the things that came out of that research was that when you start designing any kind of digital product, and often hardware as well, you think about feedback in the form of noise, and you think of it in terms of icons and things that are being presented visually. What does it mean when a device is inside your body? And it turns out that it's a whole different ballgame when you can actually feel the things that you're operating. So there's all kinds of conventions that just go right out the window. Not surprisingly, one of the things we discovered was how important usability and ergonomics was for these patients. This was technology behind their comprehension. For some of you, it's the first time you're being exposed to this technology yourselves today, and you're highly educated and intelligent, and we're dealing in many cases with people that are from rural communities. So the usability was an absolute must. One of the ways that we achieved that was to use participatory design techniques. So here we took actual patients, and knowing that there was going to be a remote control, we asked them to design what an ideal remote was going to be for them, both in terms of form factor, level of complexity, etc. So we were able to get a sense of how many buttons they want, what kind of display they were willing to deal with, etc. So we let them be in the driver's seat rather than it just being purely a creative exercise. We also found that people's feelings about what it means to have a device inside you were really profound. So thinking through how you present this technology was absolutely critical. Then we spent time dealing with the surgeons and the clinical part of it, and they have their own perspective on things. And as part of that process, we not only interviewed, but we gathered the material that they use every single day, the forms that they use to track pain, to deal with patients' discomforts, etc., to really give us clues about what the experience needed to be for them. And amazingly, but not surprisingly, the clinicians and the doctors wanted the same kinds of usability that the patients did, because it was also beyond their comprehension. And as physicians, they didn't want to spend time learning this new technology. They didn't want to learn about electromagnetism and all kinds of other things. They just wanted to press a button and the patient doesn't have pain or has their problem solved. So, in a conference like this, and when you start learning about product design techniques, one of the things that I feel really gets diminished in a conversation is the importance of creativity. Coming up with really good designs is not a formula. Everybody's looking for the magic checklist. If I do X, Y, and Z, we're going to wind up with a usable, great product. But what you're going to wind up with is a product that fulfilled a checklist. It's not necessarily a good or usable product. And for us, the creative process and how we tackled assimilating all this information and making use out of it was just as important as the research itself. And for us, part of our secret formula is the cross-functional nature of our teams, where we have very different perspectives in terms of designers, artists, and technologists coming together to solve some of these problems. So just to show you some of the outcomes, this was a design we produced for the surgeon, designed to be extremely a simple way of visualizing the placement of these controls, including connections to the hardware, extremely easy to understand diagnostic information. So they're trying to put this together and understanding where the breakdown perhaps might be in the chain of communication. We also went on to design the industrial design of this remote, and we took the emotional needs into account from the very beginning. One of the things we discovered was that people didn't want to be self-conscious about pulling out a remote in public. They didn't want people to know that they had a medical device on their bodies. So we intentionally designed it to look like a phone type of device, a modern, sexy type of device. The other thing that you see embodied here is we actually discovered in our research that we needed two remotes, a really simple remote for some patients, a more complicated remote for others. But because of manufacturing costs, there couldn't be two remotes. So baked into the design was this idea that the black represents a really simple remote, and some people could focus on that. And for people who wanted greater complexity, there was another remote, in essence, around it. So we used some trickery to address some of those human factors and emotional needs. And if you look back, you can see some of the similarities to some of the things that people represented with Play-Doh in terms of how it was configured, etc. So we tied the design back into their expression, but also our observation. We went on to design the small menu that worked on this device. And as you can see, it has some really strong color coding. And we built that color coding into the manual that we designed as well. For many of these patients, they tended to be elderly. So you can see the correlation between the colors and the sections of the manual. And the nature of the medical instructions, unlike most medications or medical devices that you deal with, it's not a bunch of words, but it is brilliantly simple ways of visualizing what you have to do. It's really hard for people to mistake exactly what they have to do when you show them where their hands should be, what button they should be pressing to get the desired outcome. You also see the really large typeface for people that had visual impairment, etc. So just to finish up, in terms of what's coming in the future, that was actually, we've designed 2 generations of that technology. That was actually the earlier one. The newer one will be something that will be out probably in 3 years, something like that, because of the length of time it takes to put out that kind of technology. So the future, in terms of wearables, you're going to see more and more about this idea of digital tattoos that are still on the surface of the body, but they effectively become invisible. That they have molecular batteries, or in some cases have batteries and generation capability that has to do with the actual chemistry of the human body. You know, we're awesome electrolytes, especially when we start sweating and generating salt, and there's a lot that can be taken advantage, and as electronics are getting smaller and smaller, there's a lot of things that you can do even with an incredibly thin component. I think augmented reality is going to play an increasingly large part in medical devices and these types of solutions. And overall, you're going to continue to hear consumers adopting this type of technology. Jordan, who spoke just before, was telling me yesterday that he knows somebody who's a dancer who has a device inside their body that buzzes every time there's an earthquake somewhere in the world, and they're a dancer, and they incorporate that feeling of an earthquake into their dance routine. So this isn't science fiction. This is here right now. And you're going to see over the next decade that many of you may wind up dealing with this question, both moral, ethical, and technological, of what it means to have devices inside your body. Effectively, looking at technology not as an adjunct to the human experience, but really an augmentation of the human experience. Muito obrigada. Thank you. Have a great day.
Give it to the other.